Hey, what's up everybody? This is Ray and welcome to our Objective-C video tutorial series. In this video tutorial we're going to talk about manual memory management in Objective-C. In Objective-C, every class derives from NSObject, and all NSObjects are reference counted. And what that means is the objects keep track of how many times they're referenced by another object, and when that equals 0, then they are deallocated. And usually when you're doing Objective-C programming, you're using something called ARC, which is automatic reference counting. And that sort of is a way for the compiler to insert all the memory management code that you used to have to add manually for you automatically. It's really handy, it's the way to go. But the reason we're talking about manual memory management in this video tutorial is so that you understand better what's going on behind the scenes and how ARC really works. Memory management in Objective-C works with a series of conventions and keywords. And keep in mind, everything I'm going to talk about for the rest of this video is when you're not using ARC, just so you can understand what ARC is doing better. Okay, so first of all, a big convention is whenever you call a method that begins with init or copy, you know that the object that's returned to you is going to have a reference count of 1. So it will stay around until you remove or you decrement that reference count, and the way you decrement a reference count is by calling the special method release on the object. And what that does is it subtracts 1 to the reference count. So here's an example. You have an object called person, you allocate it, you know the reference count is 1, so until you call release, that object's always going to be around. So in other words, if you're not using ARC and you forget to call release, that's an object that is leaked. And in other words, that memory is never cleaned up. And if you continue to do this, you'll use more and more memory and eventually run out of memory available on the operating system. Next up, a special method is called retain, and that's kind of the opposite of release. It increments the reference count. So here's an example of when you might want to do that. Say you have a method on your class that you want to set an instance variable equal to an object that's passed in. Well, you want to make sure that as long as your object is alive, you want to make sure that that instance variable you have is also valid. So what you typically do is you would, as you see the last line of this method here, you would retain that value that's passed in. You would set your instance variable equal to the value that's passed in and then retain it. And the reason you release the old value is just so whatever used to be there can be cleaned up. You see a little note here that says this is a simplified version. That's because there's a little bit of a tricky case in the case where you're calling setName with the same value as what's already in there. This could actually lead to a problem, but we're not going to get into that right now. I just wanted to show you a simple version for now. Okay, another convention is any method that you call that does not begin with init or copy. That's going to return something called an auto-released object. And an auto-release object means right now the reference count is 1, but a little later on I'm going to decrement that reference count by 1. And specifically later on means when the auto-release pool is drained. And typically that is at the next iteration of the run loop, although you can insert code to manually make that happen in Objective-C, so it's not guaranteed to be then. So just think of it as later on outside of my current scope that I'm executing in. Here's an example of a method that does not begin with init or copy. It's called quote. And what it does is it returns a quote from a person saying, give me my sweater back. So it says allocate init to create a string and then return auto release. So the reference count's going to be 1 and it's going to be decremented later. So in the next snippet it shows you calling that. So it says Ray quote, and you can use that fine in your current scope as long as you don't drain the auto release pool manually. But if you do need for it to stick around later, then you would want to call retain upon that. Just like you can write your own manual setter code like I showed you earlier, you can also mark properties as retain. So back when we were talking about properties a couple videos ago, you might have wondered, why it's not really saving me that much code to use properties. These, are very simple getters and setters. I could always write those myself. Well, when you start getting into manual memory management, these getters and setters become a lot more complicated. So I showed you kind of the simplified setter here, but I told you that there was a problem if you pass in the same value that's already there. So it gets tricky to get these quite right. So it saves you a lot of code and it saves you potential problems in this case and in others as well. The last thing to tell you is when you're using manual memory management, you have to override a method called dealloc on your classes to sort of clean things up. So if you have a lot of instance variables that you retain to make sure they stick around for the lifetime of your object, in dealloc that's the time where you have to release all of those because it's time for your object to go away, and so it should release everything that it's using. And at the end of that method you should call super dealloc. All right, so in Xcode, as usual, I'm going to use the iOS application single view application template. I'm going to call this memory test and leave everything else default, and I'll just save it to my desktop. Now we're going to create two classes here. One's going to represent a person, and one's going to represent the sweater, their favorite sweater that they're wearing. So we'll start with the sweater. So I'm going to go to File, New File, and I'm going to choose the iOS Cocoa Touch Objective-C class template, and we'll call this sweater. And it'll derive from NSObject. And just create. Now, remember, by default, when you create a project, Xcode is going to automatically enable automatic reference counting or ARC, but I'm trying to show you sort of the old way of doing things, the manual memory management way, that ARC is actually writing this code for you. So let's turn off ARC so I can show you this. The way you do that is you go to memory test and you go to your build settings, and you can search down here to find it, but in a shortcut is in the search box. I can just type in automatic and it will find the setting there for Objective-C automatic reference counting, and I'll just turn that to no. Okay, now it's off. So now I can start writing manual memory management code. So in sweater.h, first thing I want to have two different types of sweaters, the gray sweater and a blue sweater. So remember that from the enumeration video. The recommended way to create enumerations in Objective-C is the NSEnum. You give it the type, unsigned char, and the name we'll call the sweater type. And then you list out the values inside here. So we'll have sweater type gray and sweater type blue. Now inside here we'll add a property for the sweater type, and nothing changes there between ARC and non-ARC because this is a primitive type, so it's going to be assigned. It's not an object, so we don't need strong, weak, retain, or anything like that. Then we have our initializer. And I'll switch over to the .m, and I will implement the initializer. And this is stuff you've all seen before, so I'm just going to paste it in here. So literally all it's doing is it's setting the instance variable equal to the parameter passed in. And I'm also going to implement the description method. This is also a review, so I'm just going to paste that in as well. And just to look at it, remember description, that's the method that when you're logging out an object, if you use %at, it will call the description method on the object. So we're overriding the description method to return a nice description for this object based on whether it's a blue sweater or a gray sweater. And the last step is, because we're trying to kind of visualize what's happening here, we're going to override the dealloc method. And remember, this is the thing that gets called when this object gets cleaned up. Now, in this object, there's actually no cleanup to do because we're only dealing with primitive types. But we still do have to call super dealloc. You always have to call super dealloc first. But for debugging purposes, what we're going to do is we're going to log out when this is called. So we're going to say %s, that's going to be the name of the method. I'll put that in a minute. And then %at, which is going to be the description of this object, deallocated. And we could just put in a string for dealloc here, but there's a nice built-in little macro here called pretty function, which you can use to print out the method name without having to type it in. And then if you change the method name, pretty function will still print out the right thing, so it's nice to use. And we'll put in self. So what's going on here is %at is self is substituted for that %at, so it's going to call description on self, which is this method implemented right here. So that's how it all fits together. Okay, so some refresher there, some new stuff. Now we're going to get into more new stuff. We're going to create a person object. So a person object is going to derive from NSObject. And we're going to pre-declare the sweater class here because we're going to have a property that's the sweater that the person's wearing. Now we could have imported the sweater class like this, but pre-declaring it just makes things compile a little bit faster because it doesn't have to import sweater.h to read all the details about what's there. In this case, you just are telling the compiler there is such a class called sweater, and you'll find more about it later. So let's make a property for the sweater the person's wearing. And here's the first difference. If we were using arc, we would use strong or weak, okay? But we're not using arc, so we're going to use retain. Like you saw on the slides, that's going to generate, it's going to make it so that when it implements the setter for you, it inserts a retain on the object after it sets the instance variable to that value. And we're going to call it sweater. And we'll make another retain property for the name of the person. And we will add in an initializer. And we'll also return a method to return the quote. This is the thing you saw on the slides. Okay, that's it for the header file. Let's start implementing this. Following the same pattern that we've seen multiple times. Okay, now here's the first difference. So when we set, the name is a value that's passed in right here. So we want to set our instance variable, which is underscore name. Why is it called underscore name? Because this property, what it does is it automatically creates an instance variable with the same name as what you pass in here, but with the underscore. So that's why it'll automatically create a instance variable called underscore name. So we want to set that to this passed in parameter. So we do underscore name equals name. But that's not quite enough because we want this value to be retained so that it stays alive for the duration of this object. So we actually need to call retain if we're doing manual memory management here. And this initializer does not take a sweater, so we'll just initialize sweater to nil for right now. We're not going to implement set name or set sweater because the properties automatically do that for us because they generate getters and setters for us, and because we mark them as retained, it will make sure to retain those values automatically. Okay, next let's make that quote method from the slides. And actually you've seen this on the slides, so I'm just going to paste that in here. So the reason I wanted to show you this to you is it's an example of a method that returns auto-release parameter. It does not begin with init, it does not begin with copy. Therefore, if it returns an object, which it does, it should return it as an auto-release object. So it does alloc init auto-release. So when whoever calls this method calls it, it's going to get an object back that has a retain count of 1, but later on at some indeterminate time, it's going to go away and become 0. So if the caller only needs it temporarily to, let's say, log out the quote or something like that, and it's fine. But if it needs it for a long period of time, it would want to retain that value. Next, we're going to implement the description. This is review, so I'm just going to paste that in as well. Let's go over this real quick. So if the sweater class exists, it says, you know, the name is wearing this sweater. Otherwise, it just logs out or returns the name. And finally, we're going to implement dealloc. And of course, you always have to call super dealloc at the end of a dealloc method. And now here's the new stuff. So dealloc, it's required to clean up anything that it's retained. So it has potentially retained a sweater. So it says release that sweater and set sweater equals to nil. You don't actually have to set it to nil. It's just kind of good practice to do so after you release something. And then release the name and set the name equal to nil as well. Now you might wonder what happens if, you know, the sweater was never set. That's okay, because if you call a method on a nil object, nothing happens. So nothing happens here, and then it just resets it to nil again, so we're still good to go. Okay, that is it for the person and the sweater class. Now let's add in a bit of code to try this out. Okay, so switching to appdelegate.m in application did finish launching with options. Let's start by creating 2 people. And of course, for this to work, I have to import person.h. Okay, at this point, the retain count looks like this. Note that something which is referring to the application delegate. So it has a reference count of at least 1. And the application delegate here has a Ray and a Vicky object, of which the retain count is also 1. Why? Because when you call init, by convention. Okay, now let's create two sweaters. So we're going to create a gray sweater. And we're going to create a blue sweater. The Appdelegate now has reference to two more objects, the gray sweater and the blue sweater. The reference count of those are 1 as well because we just called a method that begins with init. Now what we're going to do is we're going to have both Ray and Vicky wear a sweater each. Now my favorite sweater is the gray sweater. So let's say I wake up in the morning and I put on the gray sweater, and say Vicky wakes up after me and she sees the blue sweater, so she puts that one on. Note that now the gray sweater and the blue sweater have a retain count of 2. This is because we made a property on the person class for the sweater and we marked it as retain. Because of that, when you set that property to something, it will add 1 to the reference count. Let's say that inside the Appdelegate we don't actually need a reference to the gray sweater and blue sweater anymore because we basically passed it off to Ray and Vicky. So now we can say gray sweater release and blue sweater release. Now this is not going to deallocate it. Instead, now you see something that looks like this. The Ray and Vicky have a reference to the gray and blue sweater, but the Appdelegate doesn't have a direct reference to it. And everything's still okay because the reference count is 1 everywhere around. Vicky also happens to like my gray sweater. And so what happens on a typical day is Vicky walks in and she sees me at my computer and she sees me wearing her favorite gray sweater. And so she demands the gray sweater. So what she does is vicky.sweater equals gray sweater. So at this point you see something that looks like this. So Vicky's got my sweater, she's like yanking it off me. I've still got my sweater a little bit, so the reference count is on 2. Meanwhile, this blue sweater is on the floor or something. So the reference count of that is 0, and it can be deallocated at this point. So going back to our example again, what happens in a typical day is Vicky wins this battle. So I am left with my sweater is 0. Now you see Vicky's got a reference to the gray sweater. I don't. So the reference count goes down to 1 on the gray sweater. And at this point, I usually say something like this. I get a quote, and I log out this quote. Now let's run this. And it says, Ray says, give me my sweater back. Unfortunately, this quote typically doesn't work, so it's kind of the end of this example. But what you see here is I've called this quote method. It does not begin with init. It does not begin with copy, so it's going to return an auto-release object. So I know at some point in the future this object's going to be released. But I don't need it forever. All I need to do is just log it out right now, so it's fine. I just log it out and I understand that I don't need to do any more cleanup on this because it's going to go away. However, I do need to clean up Ray and Vicky because it's still, now we're done with these, so we still need to clean things up. So we go to Ray release and we go to Vicky release. And I'll go ahead and run this. And let's look at our console log here. So the first thing that gets printed out is blue sweater is deallocated. That's because way earlier when Vicky basically set her sweater to the gray sweater, nothing had a reference to blue sweater anymore, so that went away. Then I said, give me my sweater back. Then we call Ray and Vicky release. So when Ray is deallocated, he doesn't have a sweater, so he's just deallocated. Now when Vicky is deallocated, it calls her dealloc method. And remember, one of the things in her dealloc method is she releases the gray sweater or whatever sweater she happens to have. And so after that, then the reference count of the gray sweater goes to 0 and that gets deallocated. So everything's properly cleaned up. So that's memory management in a nutshell. To show you these last few steps here, so dealloc is called on Ray and Vicky. Vicky has a reference to the gray sweater. Then Ray and Vicky are deallocated and Vicky has released the gray sweater, and so that everything goes away and we're left with just the Appdelegate. So everything's cleaned up. So now that you understand manual memory management, I hope you can see that it's a little bit of a pain because you notice there's a bunch of calls to release here. We have to put retain in certain spots. It's pretty easy to make a mistake somewhere along the line. Say, for example, we forget to call release on Ray and Vicky at the end of this method, which is a very easy mistake to make. If we were to run this, we would have a memory leak, and you could see that for yourself by going to Product Profile and choosing the leaks instrument and running the app. After a few seconds, you see here that it's determined that 2 persons and 1 sweater have been leaked. And it gives you actually a hint here of what's responsible, and you can actually spend time digging in and trying to fix all your leaks. And this was actually a common thing that programmers would have to do all the time. Well, the good news is now with Arc, you don't have to worry about that as much anymore, and that's what we're going to get into in the next video. All right, that's it for this video tutorial, but I want to leave you guys with a challenge as always. This time I want you to create a new object in the project we've been working with called Closet. And the idea is when a person is not wearing a sweater, then it should be in the closet instead. So the closet starts out with a slot for 2 sweaters, the blue sweater and the gray sweater, and then we will take the sweaters out of the closet, put them on, and when we're done with them, we put them back in the closet. So I put the sample code to sort of test out this new closet class here, so you can add that to your project, but you have to write the closet class using some of the techniques that we've learned here. It'll give you some good practice with manual memory management, and then you'll understand a little bit better what Arc does for you and how nice it is, and then you'll never have to worry about it again, at least in most cases. So I hope you enjoyed this video tutorial. Thanks for watching, and we'll see you next time.